Hello everyone, welcome to numerical series of utilization. And today our numerical problem is a three-phase 440 volt 50 Hz 10 kilowatt 24 volt 245 rpm slip ring induction motor has both its stator and rotor winding connected in the start. The ratio of stator turns to rotor turns is 1.25. The resistance measured between the pair of slip ring is 0.04 ohm. This motor drives a fan which produces 110 kilowatt at a full speed of the motor. The torque required to drive the fan varies as the square of speed. What resistance should be connected in the series with each slip rings so that the fan will run at 175 rpm? Neglect stator resistance and leakage reactance and rotational losses. First of all, we know synchronous speed of motor is NS equal to 120 F 120 F upon P. So 120 F upon P. Okay, this is not 6. This is 50. Frequency is given 50 Hz. This is 50. And simply 120 into 50 by 24, that is 250 rpm. And you know full load slip equal to ns minus en upon ns. So 250 minus 245 upon 250 is 0.02. 250 we already find, and 245 is this. Then you can get, and the slip is 0.02. And torque at full load tf equal to output in kilowatt into 1000 upon 2 pi upon 60. So put the value out, power given 110 into 1000 into 60 upon 2 pi into n is 245. So we can get 4287.44 Newton meter. And rotor resistance per phase R2 equal to a resistance between pair of self ring upon 2. So 0.04 divided by 2, that is 0.02. And rotor resistance refer to stator R2 dash equal to R2 into k square. So 0.02 into 125 whole square. This is the turn ratio. K is where k is the turn ratio. Then we can get 0.03125. And torque developed by the motor is given as Tf equal to 3 upon 2 pi ns by 60 into v1 square r2 dash sf upon r2 dash whole square plus sf square into x2 dash whole square. And putting value of v1 is 44 upon root 3, stator being connected in a star. So sf equal to 0.02, r2 dash 0.03125, tf 4287.44, and ns is 250 rpm. And put all these value in this equation. Then we can get x2 dash equal to 0.5036 ohms. And sleep at 175 rpm is 250 minus 175 upon 250, that is 0.3. And let the rotor resistance refer to a stator per phase corresponding to a speed of 175 rpm be r2 double dash, and the torque developed with t. Therefore t upon tf equal to n upon nef square. In the question given, speed is the square is the um, fan vary as the sp square of the speed. So we can write this as mentioned in the question into 17 upon 245, that whole square. So torque at 175 rpm is tf into 175 upon 245 whole square. Then you can get 2187.47 Newton meter. And now put the value of t equal to this, b equal to this, s equal to this, and x2 equal to this in this above equation. Then we can get r2 double dash equal to 0.03 volt or 0.99, sorry, ohm or 0.991 ohm. The first value being lesser than original value is rejected. So resistance to be added in the slip ring is 0.991 minus 0.031. This is already findable upon this is the ratio 1.25 whole square. Then you can get 0.6142 uh, ohm.